IPCC report, which has been published on the present state of science regarding climate change, and whether his own reasonings and observations about where we are have been reflected in this report, because perhaps Jim's too modest to say it, but my reflection, I'm not a scientist, but on reading accounts of this report, is it read very like what Jim had written in his book Revenge of Gaia 8 years ago. That's to say, this report is catching up, it seemed to me, with some aspects of Jim's thinking about climate change. Jim.
Oh, thank you, John, for those kind words. Yes, I haven't had an opportunity yet to read the full report. It would be quite a long job, but the accounts of it in the newspapers and elsewhere, including scientific journals, are quite illuminating, and I agree with John. Yes, I feel quite flattered. It really takes what was said in the Revenge of Gaia and warns us of the dangers of upsetting that lady, who was even tougher than Margaret Thatcher.
But one of the features of your recent thinking about climate is that you've become more, I wouldn't say skeptical, because you're not skeptical about the change itself in any way that's going on in the planetary climate, but you've become more cautious in terms of timing and prediction, have you not?
Yes, well, John, I'm a fairly straight scientist, and our creed in science is you can't be certain about anything. It's all a matter of probabilities, which it makes it a bit dull, because you've got to make up your mind sometime as a human. I'm definitely not a skeptic. I think, and most scientists, I'm sure, do think that you can't go on putting carbon dioxide in the atmosphere at the rate that we've been doing without something eventually happening. Where it all went wrong, as far as prediction goes, was that the Russian and French scientists who did the analyses of the ice cores of Antarctica, which go back now, I think, nearly to 1 million years ago, those analyses showed what the atmosphere of the world was during the periods of fluctuation between the ice ages and the interglacials, the warm periods like now. They showed how the carbon dioxide and the average temperature of the world varied. And it was almost a linear connection between the two, and it was repeated consistently. And I think we all felt, somewhere around about the turn of this century, that it was a fairly straightforward matter to predict what would happen to the climate in the future. If we knew how much CO2 was in the atmosphere, we could predict it. The mistake we made, and when I say we, I'm including the whole climate community, was to ignore the fact that during the glaciations, the atmosphere of the Earth was clean. It was totally unpolluted. What few humans there were around were too small in numbers to do anything like the mess that we've made in the years subsequently. And as a result, the atmosphere that we have now is not as simple as the one that was back in the ice ages. It's a heavily polluted atmosphere. Some of the pollutants like CO2 and methane make it warmer, but others, like the aerosols, the haze, that makes it difficult to see any distance when the air blows from Europe, for example, is reflecting sunlight back into space. And there are other things we realize now that we didn't know barely anything about the climate of the oceans. And the oceans cover 3/4 of the Earth nearly, and hold 1,000 times more of the heat that comes from the sun than does the atmosphere and surface. So those two major factors make predicting what's going to happen in the future a very tricky business.
So, to what extent does that affect your view of the future of this species? One of the most fascinating parts of this new book, A Rough Guide to the Future, is that you're talking about not only the future of the planet and of Gaia as the organizing principle, in a sense, of the planet, but of how humans can adapt to it and what will happen to human society and even to human nature. And part of that is a very interesting argument you've developed, which is that humans are, of course, not the only important species on the planet, and you also emphasize in the book, they're not the end point of evolution on the planet at all, but they are very important for Gaia, in your view. And could you just elucidate what you mean for that? In other words, humans have a potential role, and the successors of humans possibly have a potential role in prolonging the life of Gaia.
Yes, well, I grew up, as I think most of us did, believing that the religious teaching we had experienced as children. Remember, I go back quite a long way, and when I was a child, you were practically marinated in religion. You couldn't get away from it, and Christian thinking was the absolute truth. I was fairly lucky because I was brought up in a Quaker environment, and they were a little bit broader-minded, the sort of people you would have found in this hall back in those days. But it's only recently that I've begun to think that far from us being just another animal on the planet, an important one, of course, from a Christian point of view, one of God's chosen people, then perhaps we are not God's chosen people, but Gaia's chosen people, in a different sense. You see, there have been two species appeared on this planet that have changed it enormously and made the kind of world we live in now possible. The first and most important, perhaps, were the photosynthesizers that turned up as single cells living in the ocean, perhaps as long ago as soon after life began on the planet. And they were the ancestors of the plants, the big trees we have around us and all the vegetation on the planet. And they're terribly important. Nothing that we do or the existence of a regulating planet could have happened without that emergence of the plants and their successors. Where we come in, we are the first species to appear on this planet that takes the energy of the sun and turns it into information and harvests information. And this is just as important, I think, we will find in the future, as the harvesting of sunlight to produce energy and fossil fuels and everything that we do. And this makes us singularly important so far as the Earth system, what I like to call Gaia, is concerned. Our very presence, as we know from the IPCC, is doing things to the planet. And then the question comes, is it good or is it bad? From a purely human point of view, it's probably rather good, because there is no doubt now that the amount of CO2 that we put in the atmosphere will prevent an ice age happening as it would have happened in a few thousand years. And for those of us who live in the north, that is a very comforting thought, that we won't be subjected to glaciers, which came down as far as London in one of the glaciations. Not a desirable state. But on the other hand, everything there has changed, because sometime, I think it was round about 1712, Mr. Newcomen, who lived in Dartmouth in Devon, was the inventor of the first effective steam engine. And he was a blacksmith, just an ordinary man, lived in the village of Dartmouth. And I think a friend somewhere in the Midlands asked him if he couldn't produce something that would get rid of the water from his coal mine that was flooding continuously. One of the curses of coal mines, they always tend to flood. And Newcomen, being an inventor, all he needed was somebody to come to him with a need. Because speaking as an inventor myself, I can tell you that this is the only and most important thing you require as an inventor to produce an invention. And anyway, Mr. Newcomen made his steam engine, and that started the Industrial Revolution because it was so successful. I think it was one of those that was the crucial step, rather like the appearance of that first photosynthesizer way back long ago. For the first time, the stored energy of sunlight in the form of fossil fuel, coal, was used to produce, first of all, steam engines, but before long, electricity, and of course, the information revolution that we're taking part in now.
So your view is that the Industrial Revolution represented not just another phase in planetary evolution, but an acceleration of evolution.
Indeed it did. And if you think about it, when you see a seagull or an albatross, those beautiful birds soaring through the air, it's worth thinking about what they came from. The paleobiologists tell us that the originator was a feathered lizard, but the feathered lizard lived over 100 million years ago. And gradually, Darwinian evolution, which is a very slow process, I mean, after all, it's taken 3.5 billion years for us to appear and be talking here. It
didn't wait that long, though.
Slow process. It took somewhat over 100 million years for that feathered lizard to evolve to the seagull, the beautiful streamlined birds we see today. Now, consider the result of evolution once the Anthropocene had been established, the accelerated evolution.
The Anthropocene being the period in which the whole planet is altered by human activity.
The period that Mr. Newcomen started, accidentally. Yes, consider the time it took for the Wright brothers' first string bag aeroplane to fly, which was about 100 years ago. And we all take nothing now, flying around the world. In fact, greatly to our loss, because we never see the ocean anymore. You used to see it if you traveled by ship. You don't from the air to any extent. And that was just 100 years. So the factor of amplification of evolution is about 1 million to 1. It's a huge thing. So it's not surprising that our computers are now getting so clever that people are worrying in California if they won't be cleverer than us. I'm a skeptic about that. I think that computers are very rational. They're built on rational principles, very much. And I, as an inventor, have much greater faith in intuition. And nobody knows how intuition works.
But even though you're skeptical about the capacity of computers to replicate some of the most valuable aspects of human thought, you also think in the book, speculate in the book, that this process of accelerated evolution could actually produce successor species to the humans, successor forms of life, including forms of life not even based on what we're based on. I mean, forms of electronic life even.
Indeed. And I think this is the thing that interests the Californian authors Ray Kurzweil and Werner Winger, I think if that's how he pronounces his name, not sure, who tend to be rather more doom-minded and think more in terms of what would be familiar to us as Doctor Who, with his battles with Daleks and things like that, of a dreadful struggle between humans and a new life, computer-based, and of course we always win in the Californian stories. I don't see it like that. I'm much more moved by a discovery that a colleague of mine that I worked with for many years, Lynn Margulis, the American biologist, her really great discovery was what she called the process of endosymbiosis, which was the one whereby the primitive cells of the photosynthesizers, the single-celled organisms that were swimming around in the sea and doing their job, and doing it well for 1 billion years or so, were encountered on one incident, it must have been, a cell that was out to eat them by a process called phagocytosis. But instead of just digesting the photosynthesizer, they came to some kind of modus vivendi, with the photosynthesizer making the food and the other cell giving protection, keeping a comfortable environment for it. And that, of course, was the first plant cell, and it's gone on like that ever since. Now, I see something like that possibly happening with us. You see, I, for one, have a pacemaker in me that, not for anything terribly serious, but my physicians thought it would be a good idea to do it because my pulse was dropping down to 25 a minute, which was ridiculously low, although it broke the Guinness Book of Records, I think, like low pulse rates. But anyway, it's been done. Now, the interesting thing about that device, it's battery operated, and the battery lasts 10 years. I foresee it won't be more than a few years before other people will be having them installed that use the energy of our own bodies to drive the thing. And so you see the endosymbiosis of the artifacts that the computer scientists make and ourselves can evolve, and at a millionfold rate of evolution I've talked about, this can be a terrifyingly fast process. Already chips have been installed in people's brains that will make much easier contact between this digital signal of plus and naught and one electronic signals coming in and what the brain can interpret as a vision or a sound. The interfacing is far easier than any of us dreamt a few years ago. So you see that the possibilities of that process are very, very strong. It'll be a long time before they breed true. One will just be carrying them around. But when that happens, as probably it will at some point, then you have a new species.
And will that happen in a Darwinian process, do you think, or in a process that is somehow controlled?
Well, the Darwinian process goes on.
Anyway.
And to an extent, it's accelerated by the other process, too. Because we talk about genetic engineering, which is, after all, an acceleration of the Darwinian process through our intelligence. Mm-hmm. So anything can happen, and probably will.
Now that you mentioned genetic engineering, I know we're going to move on at the end to talk a little bit more about climate change and where we are now and whether we should try to adapt to it, mitigate it, or whatever. But you've written quite a bit on geoengineering, expressing a complex and, I think, balanced view of that. Geoengineering meaning, I guess, is this right, the deliberate human intervention into planetary systems with the goal of stabilizing them or somehow reversing or preventing worse developments in them in terms of climate change. I think it might interest the audience. What are your views about geoengineering?
Well, my first views, when the whole process was discussed long ago, quite some time, being 10 years or more ago, was to think of it as an inventor. Oh, gee, yes, now here's a need. What can you do to do it? And there were lots of quite cunning inventions made. One of the students of that famous man, Teller, the developer of atom and hydrogen bombs, had a great idea of putting a carbon fiber diaphragm out in an orbit between the Earth and the Sun that would diffuse away 1 or more % of the sunlight coming in. And this, of course, would take away the burden of global warming. It was the kind of thing that, given the money, NASA could have done. But I think nobody felt very happy about it, mainly on political grounds, because they couldn't be sure if the Americans put it up that the other people in the world would not be denied the benefits or that kind of thing. And to come to an agreement on how to do it would be very difficult. And this kind of political difference because we are tribal animals divided into nation states, whether we like it or not, it persists. And nearly all geoengineering schemes come up against this barrier in the end. One that is much safer and simpler than fiddling around with disks in space is simply to have on every cargo ship a simple aerosol generator that, rather like one of those spray cans one had, but much bigger and powered by the ship's power system, that would spray seawater as an infinitely fine mist. And this would form the nuclei for clouds in the marine stratus layer. And it would be easy enough to install those quite cheap as a proposition, and have them controlled by wireless and switched on or off whenever it was felt that there was a need to cool the region that the ship was sailing in. Remember, the oceans cover an enormous amount of the Earth, so that it's I think, a very practical scheme, and I think one that it's useful to have on the shelf, so to speak, should climate change become desperate in the way of heating. We do have something we can do about it.
But you have expressed some concerns as well about side effects not being understood, haven't you?
That's right. You can't fiddle around with the climate without all sorts of things happening that you never anticipate.
And that you can't then control.
And it's too late to control it by then. This brings up a thing which if I might interject here, John.
Yes.
That I've thought about is I've puzzled an immense amount, as my books have shown, about why everybody is so fearful of nuclear energy. And because it is the absolutely carbon-free source of electricity. We had it running here in this country for many, many years. I think nearly 30% of the electricity was produced that way back about the end of the 1970s. And then it's all gone away subsequently, mainly because of fear, more than anything else. And I can't help feeling this harps back on our religious tendencies. I think if you look at nuclear energy, it is the energy of the universe. The only oddity in the universe in the way of energy production is human. The burning of fossil fuels. For the rest of the universe, the energy is nuclear. So first I asked myself, why are we so frightened of it? Without it, the sun would go out. And that would not be a good thing. But I kind of feel that the root of our problem here is that nuclear energy was given to humanity as an incredible gift by the scientists who first worked on it, and the inventors who led them. We used it not as a safe, clean, perfect source of energy, but in warfare as a frightful weapon. And I think we've been feeling guilty, and that is the source of our feelings of guilt about that dreadful mistake that we made way back in World War II.
One aspect of the book which I found very fascinating, you've written about it before in your other books, but including your autobiography, but there's much more which is new and fresh in here, is about your work as what you call a lone scientist. I mean, there are two features about the life of a scientist in here that you discuss, the value and importance of having lone scientists such as yourself, which are becoming increasingly rare. And the other is of the aspect of scientific work which is intuitive as much as it is rational. And these, of course, is there a link between those two between the solitary character of the scientist inventor that you have been, and artist,
yeah,
and the role of intuitive thinking, which you've already mentioned in respect of computers possibly lacking it, that you think is central to science?
I think it would be a dreadful mistake to imagine that scientists and inventors are different kinds of people. Mm-hmm. It's part of this endless subdivision. We're not. I'm about 50-50, which may be unusual, but some people are much more rational and think in scientific terms classical scientific terms. Others are much more inventive. And I think of the man who's classified as a scientist, but isn't really. He was a supreme inventor, namely Faraday. I mean, he produced electricity even to the point of having trams driven by it before they knew what an electron was. The scientists were an incredibly long way behind. And similarly, after Mr. Newcomen, it was 120 years before Sadi Carnot in France worked out the theory and the explanation of thermodynamics. And I know this myself. I've invented things that have taken me up to 7 years after people were using it to find out how they worked.
But this is one of the most interesting aspects of your life as a scientist, which is that it's led you to be skeptical of, I don't know what you would call it, pictures of the human mind in which it can be or should be entirely rational. In other words, you're saying much of the creativity, including the intellectual creativity of the mind, is not entirely rational.
It's more than that, it's irrational. It has to be. It couldn't work otherwise. You see, and the interesting thing there is all the computers we use are built on our rational principles. They use what's called the von Neumann system, whereby everything runs down in a series of steps, all the way, without ever changing, really. I admit some of the more subtle ones change a little bit, but it's a continuous thread that goes on. And it's a tribute to the reliability of the computer systems that they can work that way at all. But they would be infinitely faster and more dangerous if they use the same system as our minds work on, which is massively parallel computing. It has to be massively parallel. We know that from our own investigations.
Maybe we can now perhaps start to go back to where we are now in terms of climate change, because and human adaptation to climate change, because one of the features of the IPCC report and of what you've written in the past about these matters, but also this book, is that you argue that whatever may have been true in the past, we're now in a position in which adaptation, adjustment, is the dominant way of dealing with climate change. And in the course of that, you make some very interesting suggestions about cities, how city life, particularly actually high-intensive city life of the kind that exists in places like Singapore, can be a way of adapting to a world which will be permanently warmer, or at least from the biological point of view of the human species, will be in the future permanently warmer. Can you say something about that?
Thank you, John. Yes, that's a nice topic. Can you just remind me, what was the beginning of your... I can remember the end.
What I was thinking was, you've talked now about the role of creativity in science, and we've also talked about the way in which the IPCC has caught up with you in thinking that there may be some pretty abrupt, shocking, rough troubles
it was the
ahead.
adaptation bit.
It's the adaptation point.
That's
the adaptation point, which is that rather than trying to arrest climate change or even slow it down or even mitigate it to a significant extent, what you're talking about is adjustment.
That's right, yes. I think the whole thing is, and this is very important, and I can't stress it too strongly, we know an incredibly little yet about the Earth system. We know very little about the working of our own bodies. And in many ways, the Earth system resembles a living system. This is why it has the name Gaia, to sort of punctuate that point. And because we know so little about the Earth system, we're not in a very sensible position so far as what should we do to prevent global warming or to stop it or to do these things. We just don't know how. We don't know the consequences, for example, of suddenly stopping it.
Even if we could, you mean?
Even if we could. And as I said earlier, the climate of the Earth depends more than anything on the climate of the ocean. and the ocean covers 71%, I think it is, of the Earth's surface, and holds 1,000 times more heat than the Earth's surface. Forgive me for repeating myself. Sometimes you have to. Because we don't understand the climate of the ocean, how the heck can we predict what it's going to be sometime 50 years in the future?
So the idea that humans could take charge of this,
Yeah.
act as stewards of it, wisely control it, you think is an illusion, really?
I think it's madness, and the worst of all is our politicians actually passing laws to regulate climate and produce policies for what should be done to prevent climate change 50 years in the future. We can't possibly know what that will be.
So to go back to adaptation, one of the forms in which this adaptation could take is city life, intensive city life.
That's right. I always feel that we don't have to just sit back and take the consequences of whatever doom is before us. There are things we can do. And perhaps the most promising is to follow the examples set by the social insects, the ants, the termites, and the social insects, bees and wasps. They found, as long ago as 100 million years, that it's very sensible to live in nests, much more effective than living in sort of rival tribes running around on the surface. They still do that, but the more successful ones of them live in nests. And the termites have carried this to an extraordinary extent, whereby they have their air-conditioned towers in the Australian desert that do their climate change beautifully and keep the underground nest cool and pleasant for the termites to live in. Now, they stuck with that system for 100 million years. So it must be a pretty stable, solid one. I don't necessarily mean that London's going to be here 100 million years from now as a city. It'll probably be underwater anyway before then. But it certainly is a possibility for our future to emulate that. And as John mentions, the city one thinks of most of all in this connection is Singapore, because the natural climate of Singapore, even as long ago as early in the last century, was something like 10 or 12 degrees hotter than the worst case of the IPCC. It runs at an average global temperature now of 12.5 degrees above the planetary average. You would think that would therefore be an impossible place to live in. And even if it was ideally air-conditioned so that it was possible to live in, the land around it would be a barren waste, far too hot. It isn't. The land around Singapore is typical equatorial forest, rainforest, and everything seems to flourish quite well there. So the question enters my mind, have we got global warming right? Perhaps the example that happened 55 million years ago of what's called the PETM, that's the Paleocene-Eocene thermal maximum, is something we should look at more closely. What seemed to have happened then is that the Earth warmed up about 6 degrees above where it runs now, but there was no great extinction, all of the species. And I wonder if what in fact happens when the Earth warms up is that the polar regions and the temperate regions take the brunt of the warming, and the tropical regions don't change very much at all, but then spread right over it. And I believe, although I'm quoting paleological evidence that I can't substantiate here, that there were crocodile skeletons found in what was the small Arctic Ocean at the PETM.
So we could have a world where polar bears, as we know them, wouldn't be there, but there could be quite a lot of brown bears.
That's right, yes, exactly.
Because simply the world would have simply altered its temperature and adjusted to the new temperature.
Yes, we've got so stuck in this paradigm of global warming is wicked, it's human guilt that's caused it. We don't see it as all part of a big system change that is happening. Similarly, our change to become a different sort of species, perhaps, it's all part of the game, of the Gaia's game of keeping the planet regulated with a maximum amount of life on it.
So we shouldn't actually, I mean, we could even see climate change as a kind of form of self-healing by the planet.
I wouldn't dare say that.
Well, but if someone did, then our task as humans would be to go along with it and try to make it as humanly, as not just as livable, but even turn it to good use as it happens, because it's happening anyway.
That's what you mean by adaptation, isn't it?
That's what adaptation.
Yes, I agree.
Yeah. Before we end, just one kind of more general question. If there was, you've been a scientist now for very many years, you've worked with other leading scientists, you've worked alone a lot of the time as an inventor, and you've also thought deeply about the implications of your ideas of Gaia and the way in which they impose a change of thinking. And I think this new book will suggest other changes of thinking, new ones which you've developed just in this book. But if there was one thought that the people here, I'm going to throw the conversation I've been having with Jim open in just a moment, and so people can ask questions, is if there was one thought you would like the audience here to take from your thinking, from this book and what went into it, what would it be?
Oh goodness, you're asking him to review the book in one word.
Well, not one word, one sentence or two sentences. Is there some aspect of the book which you think is more important at this time than any other?
I'm going to cop out. I can't think of that suddenly at this time of night.
Well, I mean, I can tell you what I think it is. I tend to think it's the idea of adaptation. Because the idea of
thank you, John.
Yeah, adaptation. Adaptation can be at many levels. It can be at the level of adopting new technologies, adopting intensive forms of city living. It can involve adaptations in our way of thinking. And it can also even involve, as you discuss in the later chapters, possibly adaptations in which humans themselves change through interacting with their own technologies, interacting with electronic technology. So that to me is a very profound thought, and certainly one that it's fertilized my thinking ever since I read this book and had time to ponder it. So what I'm going to do now is we've got 20 minutes or so left. There are, I think, two or three different mics here. So what I'm going to suggest is I take two or three questions at a time. I'll write them down as they're made. So in order to maximize the number of questions and Jim's ability to respond, because I won't be responding, it'll be Jim that responds, maybe they could be relatively brief. They can be very important, but also brief. So let's take two or three. Yes, what about the lady over there?
Thank you so much. I'll try to be brief. Thank you so much, Jim, for your very interesting talk. May I pick you up on your suggestion that we should use nuclear power more? And if I don't get you completely wrong, I think you're arguing that we are stewards of Gaia and we don't understand the consequences of our actions very well. And so I wonder why we should focus on using nuclear energy in the conventional sense when we don't understand what the potential damages of having century-long waste attached to it, as opposed to using the power of the sun with potentially less damaging consequences for centuries.
Okay, that's very interesting. I'll take that down, and we'll take a couple more, and then Jim can reply. We want to spread it around, but over there, yes, there's one over there. Gentleman over there.
You say that politicians planning for climate change in 50 years is not necessarily a good thing, but what about the governments that purposefully have climate denialists on board and that take the opposite view that there is no such thing as climate change.
Okay, and one more, then we on. There's someone there I think should get a chance, because we don't want just one half of the audience to be...
The question's very simple. Obviously, climate change is very important, but before then, we have an even greater problem, and I'd be very interested to hear Jim's view. And it's very simple. By 2050, we have 10 billion people, and if you read Jim's last book, as he says, to sustain 2 to 3 billion people for 100 years, that's all the resources we have at the moment. So we don't have the natural resources for the 10 billion. And the question to Jim is, what does he think happens in 2050, around 2050, when we're at 10 billion?
Okay, we've got 3 questions. I'll just repeat them. The first one is, you've defended nuclear power tonight and in your writings. The questioner asked, I hope I get it right, if not you can correct me, since some of the consequences of nuclear power long-term may be not fully known, doesn't that mean we should be more cautious about the use of nuclear power? That's the first question.
Yes, I agree. We should be more cautious about the use of anything that's done on a large scale. But in the case of nuclear energy, there is now an immense amount of experience around the world about the consequences of using it for electricity production. The best place to go if you want to see it in action is France. They say there is no nuclear waste problem at all, because they burn the nuclear waste in the next generation of fuel in their power stations. They get rid of it by burning it, which seems to me a very sensible way of getting rid of it. They don't pile it up in great piles like we do here and the Americans do, which is a very silly way of doing it.
Thank you. The second question, and again, if I get it wrong, the person can correct me, is that you mentioned and criticized having governments being containing advisors and developing policies for preventing climate change or achieving some level of climate stability 50 years in the future, when we don't know enough to be able to achieve that or even imagine what it would mean. The questioner asked, is there not, I think, a parallel danger, or even a greater danger, he might say, of having people in government who deny that it's taking place at all? Climate deniers. Because I think there are some examples of that in this country and elsewhere.
I would agree with you. I'm sure there's a lot of climate deniers in Saudi Arabia, for example. No, the crux of that really is politicians who have a rotten job at making laws about things like this should not be exposed to lobbyists for various industries, or to civil servants who have been brainwashed by ideologues into thinking that some particular remedy is going to solve all the problems. They have a difficult enough job as it is if they're going to really represent us in the governments. And they shouldn't be given the job of predicting or pass laws about what should be done looking as far as 50 years ahead. This is just plain foolishness.
Because nobody knows.
Nobody knows.
The third question was on population. The person who raised it, I think, said that in 2050 it's estimated that there will be, common estimates at any rate, take the view that there might be 10 billion human beings on the planet. How does that affect your thinking about resources were mentioned, but also about climate itself?
I think the changes that we're experiencing are not separate. Climate change, population growth, economic instability, they're all linked together. They're all part of this event and period called the Anthropocene that started, I think, in 1712 when Mr. Newcomen made his engine. It happened in this country, and I think it gives the world another thing to blame us for. We seem to have been nothing but a sort of evil around the planet. I don't look at the Anthropocene like that, nor the other things that we did. I think it'll turn out in the end to have been an event that the great Earth system, Gaia, will weave into it the fabric of its existence and enable it to live a good bit longer than it would otherwise have done. And my last point, and I would emphasize this very strongly, is nobody seems to take account of the fact that the sun is continuously increasing its output of heat, and at an exponential rate. It too has a greenhouse problem. We know why it does it, but we can't do anything about it. But it means that in 100 million years, which is nothing in geological time spans, the sun's output of heat will be rather more than the Earth system can manage in its present form.
Maybe we need a government policy on it. So I'll take another two or three. There are some over here. There's a gentleman in the front here.
As you look forward, are you optimistic or pessimistic for the future?
Okay. Who's next? Let's see. Oh yes. Oh yes, no one upstairs. That's right. Good reminder. What about the gentleman there upstairs?
I think I've got the microphone here. Hello. In the
Yes.
Revenge of Gaia, you talked about the development of agriculture having reduced the ability of the planetary system, the Gaia system, to moderate the environment. Have you changed your view about that? Because, of course, we are gradually chopping down all the trees and planting food.
Okay, interesting question. Maybe since we've only had one from upstairs.
I wasn't actually speaking there, but...
So, I see there's one over there. Been waiting.
Hi.
Sorry, you haven't finished.
No,
Okay.
I didn't actually speak. I don't know where that came from. My question is about progress.
Okay.
You mentioned our purpose, or one of our purposes, just like the photosynthesizers, as converting the sun's energy into information. And given that, and given the pace of our life, our increasing pace of life, more technology, more science, more electricity, more consumption, what is your view on what progress actually is, given all that?
Okay, progress. I'll take four because, and one more. The gentleman up there has been waiting quite a while. And then we'll answer them.
Thank you very much. I'm very interested in your idea of kind of humans kind of engulfing the machines and become kind of a hybrid. I want to know what's your view of human consciousness and how would it evolve when we kind of incorporate the artificial machine in us? Thank you.
Okay, the first question was about optimism and pessimism.
Yeah.
I know which you are, but which are you?
Well, I'm an optimist. I think the whole set of the universe it's an endless sort of wonderment. And physicists spent an awful lot of time wondering about it and come up with the most ingenious and wonderful ideas as to how it all works. Whether they're true or not, time will tell. They seem to be consistent, which is something. What was the second question?
Well, that was the question just on whether you were optimistic or pessimistic.
Well, I'm an optimist, and I also am an optimist about evolution. I think Darwinian evolution was probably one of the greatest scientific discoveries ever. And it does so well explain what happened right up until 1712.
There was a second question, which was about, I'm not sure I got it quite right, about agriculture, because in the Revenge of Gaia, you commented on the way in which agriculture had actually, the agricultural revolution, maybe more than the industrial revolution, had changed the world's climate and changed the pattern, the use of resources and so on. And one of the comments was, is that still happening? I mean, a lot of trees are being swept away and rainforests altered in order to grow soya and one thing.
The answer is very much so. And I think when I said all of the changes that we're experiencing are part of a general change process, not really separate, agriculture comes into it. It's too easily forgotten that if you take all of the humans, even the number there are now, all of their pets, and their livestock and consider the emissions of CO2 that come from their existence alone, their metabolism, it adds up to nearly 30% of the load that's going into the atmosphere. So just by numbers alone, we're doing it. And of course, agriculture is playing a huge part in that.
The third question, which is a very interesting one, is what do you understand by progress? Which is, I mean, if it has a single meaning. You've talked, of course, about progress in science. That's to say, we know more than we did. We know more than we did before Darwin. I think we know more than we did before you, Jim. What would progress be in a planetary sense or a human sense for you? Or, I mean, is there such a thing as a planetary type of progress?
I would have thought it was measured more by success in an ever worsening environment. You see, the solar environment is a hopeless one. The sun eventually will become a red giant star, and the Earth will either be consumed by it or be just outside it, which there's very little to choose between. The two states, there certainly won't be any life in any form that we could recognize in that future. But that is a fairly long time ahead, about 5 billion years we're talking.
We needn't bother ourselves too much.
But what
about
everybody forgets, including the physicists, and this amuses me greatly, is that the sun doesn't just keep steady for 5 billion years and then suddenly become a red giant star. It's warming up all the time at an ever-increasing pace. It's got global warming far worse than we have.
And the fourth of the four questions we were then asked was about consciousness, and particularly human consciousness. And as I understood the question, it was, you talked about a symbiosis of some kind between humans and machines, and even an accelerated evolution occurring in the context of that. Are you talking about some change in human consciousness itself? Or will it, that's to say, I mean, people have talked, including Kurzweil and others, about forms of consciousness developing which are sort of larger than individual humans. They may be found in machines as well as humans, or even in some merged forms of, or is consciousness actually not that important in this context?
Well, the American author Ray Kurzweil talked about there will be a singularity, whatever that may be, in about 2030, when the present rate of growth of computer thinking, if you can call it thinking, reaches and surpasses human level.
Yes.
And remembering Moore's law, which says it doubles every 2 years roughly, it's going to go on doing it. I don't subscribe to that. I think that is a pessimistic view of our relationship with our artifacts. It's rather similar. We shouldn't be dismayed that the computer that sits on the desk in front of us, our ordinary PC, can do the most incredible feats of mathematics that no human on Earth could do. It can calculate all of the prime numbers that exist up to some whatnot in a tiny fraction of a second. Now, this is something that none of us could, no human could ever do. But it's no more significant than the fact that an airplane travels a heck of a lot faster than we can run. It's just one of those things that we have made and is rational.
I think some of Kurzweil and some of his followers, and Kurzweil himself, of course, would regard it as a great step forward, this singularity, as well, in some respects, which they would think the increased speed and reach and power of thought beyond what's possible for humans would be an enormous advance. By the way, the dating of it, I think he started writing about it, if I might be wrong about this, I think it was going to be 2042.
Was it?
Yes, but that's a long way away. So it's been advanced now, I think, to 2030.
Well, you obviously catch up with the 2050 one of the
but it's an interesting, I've written a bit about this myself, it's an interesting conception because it can be taken as something threatening for human thought and as a kind of great advance for it. Well, maybe what I can say at this point is my thinking, not just tonight, but very much so tonight, has been greatly enhanced and opened up, as it always has been in my conversations with Jim and with reading him. And I benefited also directly from the conversation I've had, but also from the questions that have been asked and Jim's answers to them. And I hope you'll take the opportunity to, many of you, to buy a copy of this book and see the full range of what it contains about accelerated evolution, about adjustment to climate change, and about the two different types of scientific knowledge and discovery that occur, both creative and rational. And before we do that, though, perhaps we can thank Jim for coming here tonight and giving us the benefit of his thoughts.